All right, all right, all right, all, all right, all right, all right, all right. Thank you again for joining us. Thank you for joining us for today's session. Thank you for joining us for today's session. And we'll just go ahead. If you are connected, type connected. If you are connected for our second session, type connected. If you are connected, type connected. Let's see those who are with us. If you are with us, type connected. Connected. So thank you for joining. Thank you for joining. Great that we have us back again. Happy to see us again. So if you have been with us from the beginning up to this point, you can type 100%. If you have joined us somewhere halfway, type 50%. 50% if you have joined halfway. If you have started with us from the beginning, type 100%. 100%. So for those that have joined us 100%, thank you so much. Thank you so much. Thank you so much. We are nearing the end of this bootcamp to get us ready. I think we will do one more session for day 19. And then day 20, we go back to front end. We want to connect front end and back end together for day 20. Day 21, we are going to do interview session. We are going to take a look at handling algorithm questions, general interview questions. We're going to look at that before we disperse. After that, we can continue on the mentorship program. We'll probably be having another session for mentorship, which will probably be 30 minutes, 45 minutes session, probably once a week. All right, that said, let's get back to the business of the hour. So the other time I was talking about Jdbc. We have looked at database, setting up database, creating database, setting up table, creating table, inserting records into a table, fetching records from this table. We are also looking at filtering out jargons from the results, or filtering out to have specific information that we are looking for using what we call the where clause. We also see how we're able to, group data using the group by clause. We'll probably look at you can add one more stuff to yours, which is you can add ordering. You can have order by, which should be the last in the list. It should be the last. Is more like a good to have, so it can't stand on its own. So you have a complete query, and after the complete query, you may want to add order by to it. Order by, so any column that you choose to order it will sort it by that. Let's quickly take a look at the department table that we had earlier on. Let's quickly take a look at the department table. I'll go back to MySQL terminal and we'll look at the department table that we created the other time. The department table, and in the department table we can say, okay, select star ID name, from departments, and then we have code from departments. And then here, so you will see we have electrical, electronics, computer, and things like that. This is how it is declared, because that is the order by which they were inserted. This is the order of insertion. Now we can decide, like, okay, we want it to be ordered by department name. We can say, okay, we want this thing to be ordered by department name. So we just add the order by clause. Order by. You will now choose the column that you want to use to order it. Here, the column we want to use name. So we want to use the name column to order it. If you take a look again, you now realize that the arts and education come first, now in alphabetical order. Computer science retain the second position, while electrical electronics is now at the third place. That is using the order by. If you want to see, the order by comes in what we call ascending. ASC means ascending. We also have another order, we call it descending, DSC. Descending order, descending. What does descending do? Descending order from bottom up instead of top bottom, or like we have. So if you want to say order in descending order, so if your ascending order will be A to Z, descending order will be Z to A. Ascending order could be 1 to 10. Descending order will be 10 to 1. You understand? So that is how order is. So by default, the order by is using the ascending order. So if you don't put order, descending order as also, it will default to ascending order. For example, we can write the same code, order by name, descending. Look at it now. You now see that electrical electronics comes first, computer science second, and arts and education became third. This is descending order. If you look at our transaction table, sales, let's start from sales. You will see here, so we have item, we have this, we have that, we have that. So we can say, okay, we want you to order by item. We can say here, order by item. Order by item. You will see that you have all the HP laptop, followed by Nokia, followed by wedding gown. This is descending order. However, we may want to see based on the quantity that was sold. You want to see based on the quantity that was sold, we can say order by quantity. Order by quantity. You can see, like I said, by default it will be in ascending. Now if you order by quantity and say in descending, which means I want to see the top one, I want to see the top item. So you can see now we have a wedding gown with 13. You have see 13, you have see 5, you have 2, and 1. That is like ranking. If you want to rank, something, so you have this. Having said that, you can also you can use multiple column to order. For example, let's say I want to see each of those items, but by how much sales quantity that they have sold. So which means that I can say, okay, order by, instead of saying order by quantity, I can say order by item, then name, then quantity. So what I'm saying is that it will first rank all the items, then within the each item that matches, it will also rank by, by quantity. So you can see here we have all the HP laptop first, you can see, and then I can now put descending again. If I put descending, you will see that I have HP laptop, the first one with 5 quantity, the second one with 1, followed by Nokia, there was only one Nokia, then wedding gown, the one with 13, and then followed by the one of 2. So that is ranking, that is using order, or you can call it maybe sorting. You can sort in ascending or descending order, and you can use multi-column, to sort. You can sort by multi-column. For example, I may want to look at item by cost and quantity sold. So let's say I want to, instead of the item, I want to look at cost. I want to order it by cost and quantity sold. If you do that, then you see that we have what? We have a cost of 20 with 13. We have cost of 30, and then you have cost of 89. So that is sorting by cost and quantity. All right, so we'll go back to our Jdbc. So good. So let's move on. So we are back to Jdbc. And I said that Jdbc is Java database connectivity, which is a way of using Java to connect to database and retrieve data or manipulate data. And I give steps to connecting to database and working with data. First, we have to load the driver, which is using the class.forName, and then we have a connection class by making connection using the driver. After that, we create a statement. After creating statement or prepare statement, we execute it. Then we get a result set. After that, we close the connection. So, and I said that, okay, let's have a class that will handle collection to database for us. That is to connect and disconnect. Connect and disconnect from database. Let's have a class to handle that. So, in our class, we have a DAO, isn't it? We have a DAO folder. In the DAO, we can create DAO, like I said, data access object. So let's put our DB there. New file, I'll call it db.java. So we have a class called db.java, and this class, we said that what? It must do 2 things. You must make connection to database and disconnect from database. So let's say public. When you make connection, it should return a connection object. So connection, connect to database. That is it. And then the next one, public void disconnect. To disconnect, why are we disconnecting? We are disconnecting because when you connect to the database and you don't disconnect, you are keeping the connection open forever. You are keeping the connection open forever and may not allow other people to also connect where they need to connect. That is one. Two also is that it can end up, if others are doing that and many people are opening connection and not closing it, it leads to what we call connection leakage. And somebody can log in or connect and be seeing a different data other than what is expected to be seen. All right, so we have a connect and then we have a disconnect. So to disconnect, we need to have a connection object. So connection. So we need to have a connection object that we need to disconnect from, right? And this connection, of course, our package now will be bootcamp.edu.io, and then you need to import connection. Import connection. Connection is in the java.sql connection. Can we see connection? So we have connection now. So here we want to connect to a database. To connect, you need the IP address and port, which generally leads to what we call database URL. So db say URL, and then we need username to make connection, and then we need the password to make a connection. So we have a username and then we have a password. So of course we expect that when you expect that an action may throw error, when you ever say that it can throw error, you put it in another block. That block is called try catch exception. Try means that whatever thing that is inside try can throw error and it may not throw. However, it is very likely that it can throw error. So that is why we have the try. So we call it try catch exception. So when you do try, whatever thing that is in block, when the block closes, we have catch. So the catch is that when there is an error, whatever error that is thrown will be thrown to the catch object so that you can catch it, and then you can deal with whatever thing in the catch block. So catch error are actually called exceptions. Catch exception, and then when you catch the exception, you can write whatever thing happened to the console so that you yourself will know how to deal with the exception. So that is it. That is the try catch exception. So let's start. In the try block, first we need to register our driver. Register the driver. And how do we register? If you go back to what I wrote earlier on, is that you register a driver by loading the driver name. That is the full qualified class name that is provided by the vendor, the database vendor. So whatever that is provided, the database vendor, So if you are on, if you are here, you are connected, and you have not liked the video, please like it as you remain online. Like the video. If you are not seeing what I'm doing, you can refresh your browser. There are times that the video doesn't get rendered on time, so you can do that. All right, having said that, the next thing is that we register the driver. Register the driver. In this context, we are making use of MySQL, so there will always be a driver provided by MySQL. So we use that. So first we have class.forName. Class.forName, and that will not be the name of the driver. Class.forName. Let's define a constant, my SQL driver. So let's define a constant called my SQL driver. Final string my SQL driver equals to, I think I have MySQL here. So we'll put MySQL driver here. So we have MySQL driver. Then so we register the driver. After we register the driver, then we make connection. After we register the driver, we make a connection. So I will just say okay, we have username and password like this, like that. There is what we need to import. It's called a driver manager dot get connection. So and that we that requires the URL and the username and then a password to connect to. So this is when the actual connection to the database is done, and this method get connection returns a connection. So we'll just say connection let's say equals to null. Let's make it null. Right, so here we will now say we have made connection, so we can say connection equals to driver manager dot get connection, and then we return the connection. So we return the connection. So here, what I simply say is that get connection, assigning to this. What if there is an error that we cannot make that connection? So let's just we just say print it out. Say we can say unable to connect to database. Unable to connect to database due to the following reasons. Then let's just say, let's just print whatever trace. Let's print the trace. Say exception dot print stack trace. Now, so here is that if there is an exception, it will log the exception to the console, and we can see where the actual error is, what kind of error that we are getting. what kind of error that we are getting. So having done that, we have gotten this. Let's look at disconnect. Disconnect is that we just need to close the connection. It's as simple as that. So we can also put that in a try catch block. Put it in a try catch block, especially when you are connecting to backend or other endpoints that is not directly yours or initiated by you. It's better to put those things in try catch block, because they can actually throw any error. So I will just say the same thing we did. We just say system.out.println say unable to close connection. And then we print out the exception, ex.print_start_trace, so we can know the origin of the of the exception. Otherwise, here we just say if connection is not equals to null, and then what do? We say connection dot close. So it's a one-liner. That is why there is no call brace brackets after the if command. You can also write a one-liner like that. So we have a method to disconnect from the database. We have a method to connect to the database. Okay, so with that we can go back to our service class. Service class, and in our service class we have list of students and things like that. So in this context, we want to do what we call dependency injection. So we go to where is it repository here. Now, so here you can see that we have update, we have this, we have that, we have delete. So for every of these functions, it will have to go through to the database. And you don't keep initializing database every time. So we are going to do what we call dependency injection, which means that we'll make database class a dependency, to the student class, which is the repository. So here in the constructor, let's have db, and then here, since we already have db, we can just say okay, final db, and then here we can now say we don't need to have this dot students again, so we just change this one to this dot db equals to this dot db equals to db, which means we're injecting the db class into the students class. So this dot db, so we need to import this db. That should be in what? This should be in DAO class. So we'll call it db. Okay, now that we have db, so how do we handle this? let's just start with what is so simple, and that is the find all students. So we use that to learn the DB. So the first is that if there is no student data, or if there is an exception, we just return an empty set. Don't forget that I said that in making connection to back end or any resource that you can control, you will expect that it will generate any error or when some conditions are not met. So let's try this. In the find all, we just want to fetch all records in student table. So first we'll say that we try with our try catch and then catch, and then we'll say exception here. So here we need to make connection, isn't it? So let's say we open connection, we have connection class equals to null. So connection class equals to null, and then we are saying that here, what's the first thing we do? We need to connect to database, perform operation that we need to perform, and then close the connection. That's what we want to do. And in connecting to database, we already have a class that handles the actual connection. So we just need to call the class to make the connection. So we can say con equals to this.db dot get connection. Is it get connection or just connect? We say connect. This.db dot connect. Then db.connect as username and password, isn't it? For now, we are going to add code this. So here, let's have URL. The URL is the connection to the database, which is since it's on your system, it will be localhost. The password, I think that's password. You use your own password. You replace with your own password when you are testing, and then the username is root. And then the URL, there is a way each vendor provides the URL, but so each vendor provides his own URL. So I'm going to take care. Let's see what I have here. Okay, let me quickly search. You can search MySQL URL, my Jdbc URL, MySQL Jdbc URL, MySQL Jdbc URL. Let's find that. I think I found one. So MySQL Jdbc URL. So we'll say our URL is this. Like I said, since this one is on my system, most of what is changing is the standard is that you have Jdbc followed by the vendor name, which is MySQL. Then we have the IP address and port. If your server is on a remote server, they may just give you maybe www dot or https radiodb.ng. So whatever, they may not give you IP address, it may not be localhost, it may just be a domain name. Whichever way, you see the same way, and then the port 3306, and then lastly the name of the DB. Our own DB here is called Bootcamp. Our own DB is Bootcamp. So you can see the URL is this for Bootcamp. We have Bootcamp. We have the username and things like that. So having said that, if we go back to our students here, connection equals to this.db.connect, this.db.connect. So after that, then you can have whether statements or prepare statements to handle your connection. So let's see what we can do from here. So we can start with statements. Don't forget, statement gets compiled each time that it is run. So we can say that statement equals to connection, that is con.create statement. So we'll create the statement. Yeah. So after we have created statement, then we execute a query. Statement dot execute query. Execute query. When you use execute query, what you are simply saying is that you are expecting a result set. When you click execute, you are not expecting anything. So we can say result set. Call it result or rs equals to statement.execute query. Now this execute query requires our query. So what's query that do we want? So let's define the query. So say final string SQL, query. I'll just call it SQL equals to what we want to do is to just get all the student records. So we can say select star from students. We know this already. So here I can just say select ID, name, address, ID from students. So we have this. So this is what we are going to pass SQL into our execute query. So we need to import statement, we need to import ResultSet. So we go back here, java.sql statement, import java.sql ResultSet. So we have this. We have ResultSet. And don't forget that for our Jdbc to work, we need to ensure that we have the right driver. So how do you ensure that? You can check your build.gradle, check the build.gradle, and ensure that it has in the dependency, it has implementation MySQL connector Java. Now I think maybe also needs a way of showing that when we say dependencies, traditionally it means that the library that you need to work with, the jar file, need to be in the same directory. Just like when we have built this thing, we have a database 0.10.jar. Here your dependency is now we are looking for a jar file, and the jar file, the name of the jar file is this MySQL Java, and then you have you have this version, so this 00.jar, and then this is the owner, so it might be MySQL connector, then -8.0.28 jar file. So we need to go to the internet and download this file. Otherwise, we can make the system to download it automatically during build if it doesn't exist. How do we do that? So with this dependency, you need to tell Gradle the source, which means we have what we call a Maven, whether Maven Central or so. We just need to define our repository. Just like we have a source code repository, we also have a repository where already built files are stored. Already built files are stored. So those are the repository. So we can look for our repository and define before the dependencies. We are going to define repository and say repositories. We define repositories, so we can now give it where it can find different repository. So I think we have Maven Central. This command does something magic. It just automatically find the URL of central Maven repository. Another one is that we can actually specify it by ourselves by saying Maven, and then use a brace to state the URL. Say URL where it needs to look for. There could be multiple URL where the files are host and things like that. So let's start with, let's say, https repo.maven.apache.org, then /maven2. So let's start with this and try to build our project. Let's try to build our project. Gradle claim build. So if you see, it will make attempt to download. Let me see. While it was running, it will make attempt to download the file. I'm not sure whether you saw that when it was running. Let me see. Let me see. Okay. try see. Okay. Yeah. Right. Which one am I doing? I think there's an error in what we are doing. Let's quickly fix that first. New student is not compatible. Okay, in student service. Okay, so we have DB. We go to service, student service, has new student. That means our database DB must be a dependence. A dependence to this, and then new student DB, because the student constructor requires that. Let's fix that. Student service, and then in the app we have to instantiate the DB. So in the app, let's just say while the app is starting, we can say new DB. All right, and we need to import the DB. Okay, that's already imported. Okay, so let's try and compile again. Let's try and compile again. One more error. Okay, cannot find symbol DB in student service, so we need to import that in student service. Import bootcamp.edu.db bootcamp.edu.db. All right. In the student service, right? Did I save it? Oh, sorry. DAO student service.dao so we do that, and then finally in students, line 50 students, that should be here, line 50, student repository, line 50. So we have the result set, but we need to return students. Okay, currently I will just return, just say return list.empty set. So list.off anything that will return an empty list. That's list of students. Then if there is any error, we just return same empty list, return new array list, return new array list. Let me just do the same thing here. Self new array list, right? Return new array list. So, but let's say there is an error. Before we return that, we can print out whatever error that we have. ex.print start trace. I'll leave it that to move faster. Now that we have this, okay, so it built successfully. Now we need to run through. Let me run us through what I did before we move back. Let me walk us through. Number one is that you make a connection to database. After you have made the connection, you create a statement, and you use the statement to execute a query, and then they process the query that they have gotten and return whatever thing that you can get. So in this context, what we get is a result set. And finally, we need to disconnect. Finally, we can say this.db disconnect this connection that we currently have. So first, make a connection to the DB. Second, create a statement. 3, if you are expecting results, process the results, and then you can retrieve your data from it and send it back, and send it back. If it is just this one that we can do, let's get it right and send it back. Now, to make the connection, we create a special class which is called DB. And the DB, I said to make a connection, first you need to register the driver. You need to register the driver by the driver name. Here we have the driver name for MySQL. After registering the driver, we need to make the actual connection using driver manager.get connection. Driver manager.get connection. That will give you a connection, and then you can return that connection. Otherwise, it is null. We have another method to disconnect from that database. If it is not null, we can just disconnect from the database. Okay, having said that, I'll go back to the beginning. Which is dependency injection. Don't forget, when we're treating what you call a solid, when we're treating solid, let's see, solid principle. I talk about what? I talk about single responsibility that a class should be able to do one single thing. Will be responsible for that very single thing. Then I talk about open, which is the O there. Open means that it should be closed for modification and open for extension. That is adding new feature. But if you want to add a new feature and continue to modify the class, it's better to extend it. And then we have the dependency injection. So for classes to be testable, to be reusable, let me put it this way. You realize that the cars that are being built today, you can go buy tire from different places. You can buy a car in Europe and then take it to UK, buy a tire in UK to put there. Or you can take it to Africa and if it has problem, you can actually buy, tire in Africa to fix. So which means that the car is designed in such a way that the tire is not tightly coupled. When we say something is tightly coupled, it means that they are totally part of them. They are totally part of them, and once you remove it, that's the end. That's the end. So with dependency injection, we are talking about what we call loose coupling. Loose coupling. That is that not bound to a particular class. Not bound to a particular class. That is loose coupling. Loose coupling. And that loose coupling enable what we call dependency injection. So you can inject what you need into another class that requires it. You can inject what you need into another class that requires it. That's what we call dependency injection. For example, I need a class to create multiple students. So I could have a class that is generating students. So I will inject that. So it becomes like another way to look at dependency injection is to see the dependency as a tool. Is to see the dependency as a tool that need to be used. Okay, so let's take a look at this. In the kitchen, you have cooking utensils which you can buy and replace. So whatever thing that you can buy and replace at will is a dependency in the kitchen. You want to make stew, you probably need a pot, you need to have a stove, and then you need to have a meat and things like that. But you don't have a farm. You don't also manufacture stoves. So you can buy all those stuffs and bring it to the house. So the thing that you can get outside and use is reusable. So that is a dependency that you need to fulfill. Whatever thing that you need to fulfill a task, that is what we call the dependency. Whatever thing that is needed to complete a task is a dependency. So that's another way to deal with it. So we need access to database. We need access to database to fetch record from database. We already have a class that is taking care of access. We don't need to now write the same access code in our class. That will be tantamount to what we call code duplication. That will lead us to what we call code duplication. So we need to do what we call loose coupling. We need to have injection. Let's say we have a file system that we also need to connect to. We can have a file handle as also a dependency. Currently, some of the things that don't need to be recreated, for example, database doesn't need to be recreated once the application starts. So we can start it once. That's why we are making it a dependency. Once we create it, then we can pass it as value to every other guys that need it, to every other classes that need the database connection. Something is doing database connection. That is why we can get someone to patch tire anywhere you want to go to. You can get a mechanic to fix a car, at any time. You don't have to be the mechanic yourself. You don't have to go and learn to be a mechanic just because you want to ride a car. So that is how dependency is. The thing you can get, you can collect and use, and they throw back away. That is, maybe pay the mechanic off and you move on. So that is why in our class, as we are starting, we start by initializing DB. If this looks too big for us, we can just say, let's say, okay, DB equals to new DB. We instantiate it, and then we pass the value, the variable, into student service. So student service will not need to now go and instantiate DB. Student service will not need to go and instantiate DB if you just make use of DB directly. So if you go to the student service actually need a student repository called students, and the students require a DB. So what are we doing here? We are just passing the DB that we have here into students. Now in the student repository, we also have going forward, I'm going to change this. I'll call the student student repository for us to be more aligned. Instead of calling it students, we are not dealing with in memory again, so I'll just say student repository. Student repository. Okay, so we have student repository, we have student repository. So, and in student service we make use of student repository. I hope we are getting it now. Students service has DB, so we pass the DB to student repository, and student repository needs connection to DB, and they can make use of the DB we have to do the actual connect, right? So this is what we have. I will compile or rebuild the project again to be sure that we are still in sync. Otherwise we'll fix whatever error. So in student service, we need to, this should be student repository. Now from repository, okay, so build successful. Now all we have done so far is just let's test whether our connection actually works. Our connection to database, if it works, let's check, right? We can just say if it connected, we'll say system.out.println connected to database Bootcamp. Now, so if it is not connected, we are going to get the second warning, which is unable to connect to database. Let's attempt to do that. We'll just run our code as it is. We'll build again. After building, then we try to test. Say Java, then jar. What else? We have leaves. Leaves. Why? Leaves slash. I think it's build first. Build slash leaves. And then slash database.jar. Now, so we have a null pointer exception. Null pointer exception at the add. Okay, so because the students were not instantiated, so we just do this. Where's the app? Where's our app? In the app, we run create service, isn't it? So we run create service, and then we did print. So, and in the print, what did we do? In the print method, what did we do? We had the student service.print. So we probably let's leave this out first. Since we have not implemented the database for that. Let's just print. What does print do? Let's look at what print does. Print in student service. Let's take a look at that. Print. Okay, student of find all. That's good. So let's build again. And then we are trying to attempt to run it. So we see have okay, now we have class not found exception. So which means that the driver is not loaded. Loaded. Say class not found exception. Now, so if we take a look at that in our driver, we have build, we have libs, we have database. We need, okay, this is not a full it needs the dependency for us to actually work. The database at this, the Java at this point, we need to have it in our class part. We need to have the MySQL in the class part for it to run. Well, in our next class, we will see how we can bundle everything together as one jar file. So currently, we just need to go and download that file. We just need to go download it or look at our class part, whether we can find it. It should be in M2 in the users. Let's see. In the users files. In the users files, we should have M2. M2 for Maven. Okay, let me take the faster route. The faster route will be to just go and download the connector. I will try and download the connector. Let's see. But actually, it's supposed to be in the folder. So let's download it. Which version are we using? In our graduate file, we are using, where is it? We are using MySQL connector 8.0.28. So let's look for a jar file that matches that. So you can just Google MySQL 0.0 connector .jar 28. I saw 30, but it will work. But let me try and download the 28. Let me download 28. Where can I find that? The jar file. 28. Maven SQL connector. SQL connector. SQL connector. SQL connector. I think just you can just try and also download from your end, because I will not push this to the repository. So if you go to Maven, repo1.maven, I think we should be able to find it there. So I will just I will share the URL with us. You can download from there to your own system. So look for MySQL Java 8.jar, the one that has just .jar, and download it. Okay, so once that is downloaded, I need to pick it from where it is and put it in my development folder. Say copy. I will go back to your, what is it called now? Go back to your, if you are not seeing what I'm doing, you can just refresh your browser. So after that, go to the folder, your bootcamp folder, in the bootcamp folder, we have the database project, right? So in the database project, I'm just going to drop it there. So if we go back to our code now, then let's attempt to run again. We will now have since it's not just one file, we need to indicate the class part. Instead of jar, I will just say CP. CP means class part. So current class part, current class what's the file name? This, and then separate by semicolon. That is if you're on Windows. If you're on Windows, you use semicolon. If you're on Linux or Mac, you use I think colon. You use colon. Let me see, colon. And then the name of our app. App name, that is bootcamp.edu.app. Could not find build.libs. Let me see. Like class part. Let's see. We have cp mysql connector.jar, bootcamp.edu, this there shouldn't be space in between. Good. So we can see now that I say connected to database bootcamp, connected to database bootcamp, connected to database bootcamp. If you have downloaded the same file that I asked you to download, and you put it in the root of your database project, then you run it this way. Let me post the URL. That's a bit of modification that we are doing. So that will be how to run it, because we need the jar file dependencies. We'll see how to overcome that when we are doing a Spring Boot. So that said, now that we have been able to establish connection, we can go ahead to fix the rest. If you are not catching up, you can just refresh your browser to see where we are. All right. So since we have the gradual fix, we have the dependency fix, let's go to the student repository class. Here we have done nothing. We just simply return an empty array list. Now, if our result set, if the execute query actually works, it will return a result set. And then how do we handle the result set? We just put an iterator, because the result set is actually an iterator. You remember when we are doing iterator, so we have while loop, while result dot has next, or while result dot next, right? While result dot next, which means that as long as there is record, I think while result dot next, while result dot next, that's the how to iterate through the result set. While result dot next, the result is the collection, and then dot next is to test if there is an item within the result set. As long as there is an item, then we can get the result set is actually contains the record. Do you understand? The result set contains the records in the database. Each object within the result set is each object within the result set contains all the columns. So we can say string name equals to rs dot get string, then we put the column that we're expecting, name, rs dot get name. Don't forget result dot get string name. Don't forget that the result contains all the columns. The result contains all the columns in the table that we are dealing with, and we are selecting from student table. So we have this column, so integer id. So based on the type of the column, you map it back to Java type. Integer id equals to results dot get int id, because ID is an integer. What else? Integer. Address ID. So let's call it address ID equals to results dot get int, right? And it's called address underscore ID. That is the column name. So that's the column name. Let's not forget. Let's look at it again. So in the result set, we just need to loop through the results. We just need to loop through the results. And when we loop through, we use results.next. Why result.next? Now within the block, we can now fetch all the columns. We can fetch all the columns and put it in our what? In our list. So let's just say from here now, we can just say list students, since we don't have students again. So list students records equals to new array list. Since we have instantiated this record, or let me call it students equals to new array list, then here we can now say student equals to new student. Student just as name and address. Name and address. So this is not correct. So we now say students dot add student. This is very important. I need us to just look at it very well. So we do a loop to what the database return using the result set. We loop through the result set, and from each of the result sets we try to fetch each column. After we have gotten each column, we construct our object back, put it in the collection, and then finally we return students. Finally we return what? We return students. So if we do that, it means here we don't need to return anything, right? So we don't need to return anything. So once we do this, we can we'll now see that address object is not constructed, but we have address ID. Student also, the ID is not there, but we can have a student dot set ID, and that will we'll put the ID that we have. Correct? Then what about the address? We can just construct an empty address. We can say address equals to new address, equals to new address. I think it has state, city, and code. You can just empty stuff. We can also have default constructor. Then address dot set ID will pass the address ID to it. We'll pass the address ID to it, and let's make sure that address is imported, student is imported. We have a list. Okay, let's try and compile this again. Gradu build. What is missing? address.setId. So that means there is no setter for ID in address. Let's fix that in our VAO address. Address, where is the ID? We don't have set ID, so let's add an ID here. Say private string ID, and then we can have a set ID. Sorry, it's integer, public int get ID or set ID self. Public int set ID this dot ID equals to ID, and our ID is supposed to be an integer here. Okay, so if we go back to our repository, let's see. Address.setId. Where is address ID? Integer. Address.setId. Let's see. Private ID. Public. Public void set ID, and it take an integer ID. Okay, so we try and do it again. Okay, now it's successful. So now that it's successful, the next thing is for us to run our application again. Now we have a null pointer exception at line 43. So that is why it's always good for us to print out the exception. So line 43 of the repository class was there. Line 43. Student equals to new array list. Students dot add, and we return student. Okay. Do we test again? Okay. So it comes out. This is everything in our database. This is everything in the database. We have Donald Bello, we have Top Samson and Jdbc. But the address is given empty because we did not fetch the address. We did not fetch the address. So what should we do in this context? We can go ahead to fetch the address. And write another query, but it's not too good a practice. So, but we are going to start with that, and then later we improve on the performance, and I'll tell you what to do. So currently, what we are going to do is that we are going to do another result, and then this result we'll call it result 2. Here in the result 2, or let's say address results, let's do it that way. Address results. Here let's write an address, because we are dealing with statements. So SQL2, which is for address. Select ID name. Okay, address as what? Straight. address as city, and address as what? State. From addresses. Now we are getting address per student, so where ID equals to, so where ID equals to this. So what we simply want to do is that we will take address table, we take address SQL, we'll call it SQL2 now, plus SQL2 plus our address ID, plus address ID. We execute this query, and then the same while that we did, execute query, then we can put while here and say while address 2, while address 2 dot as next. We can construct address from here. We can say if it asks next, we just say we'll just say the same thing we did here. We'll just say okay, string street equals to address results dot get string street. So we get street, right? Like that. We have street. So you do the same thing for city and state. So we have a city, we have city, we have state, and then we have states. And so once we have this, we can now say street, address city, address state. Right, so when we do that, then we can now say where did we set the address? Student does set address. After we have the address, then we can construct students here. We can construct students here. This we expect one address per student, this, and then we add this. If I let me take everything. So we do this. Let's see if this works for us. So first we create students query to fetch student query. Then we use the address ID to go and fetch the address details. Let's try and build this. Let's see. Let's try and build this. Okay, build successful. And then let's try and run it. Okay, so here it said that the result set is closed because we're executing this query before we move to the next. We're using the same statement. We're using the same statement. Let me see what we can do with that so that we don't close the current result set. that current result set I've closed. Address results, while this was this. Okay, not to waste time. That's what I wanted to say before. Because we have to do multiple query, we have to do multiple trips to the database. At first it works. Now, because we need to, that's like an inner loop. That's like an inner loop. How do we fix this? We can make use of another SQL strategy, which is called union. Okay, let's get there and fix that. Let's do some relationship marriage. If we go back to our MySQL console, we can learn this, that is called union. You can refresh your screen to see the new terminal. So the union, we want to learn union keyword. That is how to maintain a relationship. There is union, there is also join. Union, join. We have left join, and then we have an inner join, outer join. So we can take a look at that. So we are looking at union, especially for the sake of what we are doing now. When you use union, you want to merge. You want to merge all the columns in more than one table together to form like a single row. All the columns of a table, you want to merge them together, especially when you have a one-on-one relationship. How do we do that? You use union. Now let's take a look at it. We have address table. Select ID, state. Select ID. Select ID street, city, state from select ID street, city, state from, where is it called? From addresses. So this is the addresses that we have in the table. Selecting ID from the table. So we have these addresses. Now let's check student also. Select ID, name, address ID, ID from students. This gives us this. So we have two tables. We have two tables of students. We have address, and the student table depends on the address table, because the student has the address object. How do we marry that together? We can use this technique called union. We can join two tables together by using union. So we'll say select ID, name, you understand, address ID, street, city, state, from addresses, from students, then union addresses. You can see union addresses where ID equals to address ID. Okay, so with this one, we might have to do we give them a label, variable label, and things like that. So this query, let's say student has an acronym. Okay. Acronym S. So we just say s.id, s.name, s.address ID, and then for address, call it a.city, a.state. We now say from student S, union addresses. Union addresses, A, where s dot id s dot address ID equals to a dot ID, where is the address. So where's student union addresses A, where in fact we don't even need wait, I might not even need the union. We'll just say comma student S, comma addresses A. Okay, bootcamp addresses doesn't exist. Addresses, where is it? Where is this? Student S addresses. What's the spelling of my addresses? Addresses A double DRE, I think it's double S. Oh, good. So here you now see that we are joining two tables now. We are joining two tables, and from here you have the student ID, student name, the address ID, street, city, and state. So we can just take this back to our code. We can take this back to our code. and update our code. Let's go back and update our code with this query. Let's update our code with this query. So instead of writing two queries now, we are writing one query that handles everything. You see? So we have one query that handles everything. So we have a select. We have a select s.id this. To make it clearer, we can just we can make it a multi-line. We can make it a multi-line plus this. I'll just see from student S address A, where A the student ID, student ID equals to this. So if we do that, we will then need to write the second where clause. We will not need to write the second where clause. We just take this. I mean, there is no second inner query now. So we have the ID, we have name, we have the address ID. We have address ID, and then we have the street. So it will be the same result. The same result. Okay, so let's try that again. Let's build and then let's test. So it works now. It works now. So that is it. So how do we do the rest? We can use this concept, to deal with the rest. You see the same code, but like find by ID now. If we go to find by ID, what we'll simply do is this. I put the code again. See the same stuff, but this time around we need the ID. So that we not get just a single record. We need the ID. So here we select, and then we have the where clause. To make it neater, let's do it this way. So we select, then from these two tables, where this AID equals to that, then in clause, conjunctions. In your conjunctions, you can have if this and to join with another one, or with. So we also have conjunction. We cannot say where this is this, we can add another another condition, and s.id equals to question mark, or equals to whatever. Since we are not using prepared statements, we just leave it at that and pass the ID here. So here I'll just say plus ID. So not necessarily doing that. I think I can do that from here. Equals to then plus ID, equals to the input ID. This needs to have a plus, right? Now, and what we are returning here is what? Is student object. So the student object, we just say student, we initialize this to null, a single student. So here there's no need to get the ID. We already know the ID which is being passed. Here we are not adding it to collection, we just get it, the student, and here we return null if there is an error for the student, and finally we close the DB. Here we return the student. So that is it. You can see the same code. We'll try and refactor this in another way. So that is what if we want to add a new student? All we need to do is to construct the same thing. I will just say, I will just do this. I'll copy this, and to add a new student, all we need to do is that we generate ID, right? We generate an ID. There's a way we can also auto-generate an ID. Okay, so let's say we have this. We don't know students.size. So here, what do we do to get? Let's just generate any ID. We can use math.random. Math.random will generate a number between 0 and 1. So times 1000, and then let's cast it to integer. So what this is doing is just to generate a number between 0 and 1 multiplied by 1000, which means that we are generating a number between 0 and 1000. Then this is just one way to do it. Other way to maintain our ID, we can actually we can get the students first, get the size of the students, and after getting the size, fetching the records. So which means that for every time we want to insert into the student table, we will be fetching the records first. That is double trip to the database. So it's better to just generate an ID. We'll use this one as a generator in the first instance, or we'll maintain a sequence within our application, which is also not too good. All right, so that is one. Here our statement will now be insert into students, right? Inside into student, we have ID, we have name, an address ID, then values. What are the values that we want to add? And each value should be in apostrophe. So what about the address? we also need to do the same thing for address. So we say string SQL1 so we'll close on this. We'll close from this one. We're able to insert. We're already able to fetch. You can implement the find by ID. I think we have already done that, right? Okay, so this one will be insert into addresses. Then the ID. What else? ID. ID. Street, city, state, then values, all the values to be there. So all the values to be there. So we have here we are going to execute two query now. And then because we are not expecting results, it will just be execute. It's just a statement dot execute, and we don't need while. We don't need a loop because nothing is returned. So no while loop. Nothing is to be returned. We only do what? We only connect and disconnect, so it should be cleaner. So we are going to execute the first statement, which is for address. After inserting the address, then we start the second statement, which is for the student, SQL2 for students, or student query address query. Now this is not complete. We now need to put all our values. The way I like to do it is that you just open the brackets and say plus. So they have to be in quotes, except the one that is just integer. So I will have this is say student name, and then I have address ID. I'm going to use the same ID for address this. So we have values ID, where the second ID is the address, and the third one here is the name of the student. Name of the student. So we get it now. Let's say this. So you can make more meaning. We'll do like this. Values. So values what? And these are the values. ID, plus because they have to be in the string, plus the name. The name has to be in apostrophe, this, then comma, ID, plus Let's code this. We're almost done on this, so we'll leave it. So here, the student name, we can just say student dot get name. Student dot get name. Okay, student dot get name. How about the first query? For the first query, we also have values. For the first query, we can have values. ID in this context is still going to be like we did before, plus ID, and then plus we continue the quotes, command, and then we have string plus what you can see it's a bit it's not too tidy for create statements, because the value has to be passed this way. When we start using prepared statements, you will see how neater it is. Okay, so address dot so we can say here address equals to student dot get address. Student dot get address. Now, so we will have address dot get name, dot get street. Address dot get street plus the next one is what is plus address dot get city all right. So we also call that, and the last one address dot get plus address dot get state. Okay, I think we are home and dry now. So, and this is it. So we see the two SQL, and so we execute these two SQL, and if you compile, let's fix this. Student variable is already defined. Let me see, students, when did I address where is student constructed? Student constructed address line 64. Okay, line 64. We already have address, we have student. Where is the student here? Okay, so we just say student here equals to new student. Okay, then we return student. All right. So let's build again. So, and that's it. Why is the address dot get address? No, there is no address dot get address. It's street. It's street that we have in the address. Is address dot get street. Is address dot get street. We use street, not address. So that will be for today. We meet our next class. We like we normally do. We take a refresh on what we have learned today before we move to advanced concepts using Spring Boot to handle this. So we'll look at prepared statements tomorrow. Just practice this, and I want you to implement. We already have find all. Okay, I want you to implement the update and delete. Here we are using the in-memory database. So for update and delete, I want you to implement it using direct connection to database like we have done. So I want you to make use of Jdbc for the update. That's your assignment. The update, and make sure you push it. I want us to start early also tomorrow, so to see whether we can have 2 sessions. Thank you so much for listening today. Thank you for partaking. Well done, all of you. We are getting there. Bye for now.